Okay, so you have seen a couple of slides of this presentation already, but I wanted to introduce OLCI. How many of you are working with OLCI already? Okay, so I know many of you know it, but for those that are new to the sensor, I think this is a good starting point. I won't be very picky, so it would be something quite general, but at least you will have an idea of what you can have. So I have to start talking a bit about EUMETSAT. What is EUMETSAT? Inside the European remote sensing community. So it's as I say, it's an intergovernmental organization. The EUMETSAT responds to the European Organization for the Exploitation of Meteorological Satellites. It's located in Darmstadt in Germany, and actually there are 30 member states, not all of them European, as you see in the map. And it has two mandates, so to provide accurate data, weather and climate data for the member states, and also to add additional capabilities within the European Union and beyond, and it does it through the Copernicus program. So I have to mention that EUMETSAT and ESA collaborate. ESA is the European Space Agency. European Space Agency is the one that is in charge of putting the money to building the rockets and the satellites and the sensors that are later exploited or processed by different agencies, and among them EUMETSAT. So there are three big branches of the European Earth observation missions. There is a science branch, and within this science branch, there will be some hyperspectral developments that will be important for us in a few years. Here we have the Copernicus satellites, the Sentinels, and some others. So we are now more or less 2024. We have several Sentinels already in orbit, and the ones that I will talk about today is the Sentinel-3 series. There are two in orbit right now: Sentinel-3A, Sentinel-3B, and I read that Sentinel-3C was going to be launched in October, but I don't think it happened. I haven't seen any news. In fact, I was looking for it. So, but it should be launched between the end of this year and beginning of next. I don't know if they launch it really. So EUMETSAT, well, and here you have the meteorological satellites. For the Europeans and the Africans, the EUMETSAT satellites are the Meteosats, the ones that give you the weather forecast in the TV, and the JSONs and the METOPS. So the METOPS, I wanted to say. EUMETSAT satellites, EUMETSAT is processing and delivering. It has a mandatory program that are those meteorological satellites, so the Meteosats and the METOP. Right now, in operation, there is a Meteosat second generation, and they launched, I think last year, the Meteosat third generation, geostationary, these ones here. Okay, geostationary satellites that take this big picture of the hemisphere of the Earth. And then it also provides data of some optional and third-party programs, including the Copernicus program, with the delivery of processing and delivery of Sentinel-3 and A in the marine part. The JSONs, that are altimeters to produce sea level heights products. And last year was launched the Sentinel-6, that is also an altimeter to produce altimeter sea level heights. Well, I'm not going to detail into the mission planning, but you have the slide there. So EUMETSAT process and distributes the level 1B and the level 2 data from those missions directly to the users. So you can download data from there directly. And they also provide these 2 levels to other services like the Copernicus Marine Service were produce the level 3 and level 4 products that you can also find. And also provides further marine products via the OCSAF, like the ocean and sea ice products that are produced and delivered using these like collaborative services. So I wanted to talk a bit about Sentinel-3 and OLCI. And Sentinel-3 mission is called the Blue Sentinel in between the 6 Sentinel program that we have now, because it's carrying a suite of instruments that is designed specifically for ocean observations. Sentinel-3 has 3 main objectives. So it's to deliver sea surface heights, acquire sea surface topography, sea surface temperature, and ocean color data, and do it with an accuracy that is decent, a high accuracy. As I said, there are 2 platforms right now in orbit, Sentinel-3A and Sentinel-3B, and Sentinel-3C is going to be launched soon. The revisit at the equator is 2 days with only 1 satellite, which is reduced with 2 with the constellation for the optical sensors. And Sentinel-3 has a thermal sensor too, that I show you in a bit, and that has a wider swath, so it can deliver and revisit the equator every 1 day, less than 1 day. It's a low Earth orbit satellite. It's polar, almost polar, sun synchronous, and it has an orbit cycle of 27 days. So the 3 instruments that Sentinel-3 carries are the OLCI, that is the one of our interests. It's a radiometer that measures in the visible and infrared and SWIR. Dedicated to ocean color, and from where we derive radiances, reflectances, and water quality, the 3 aspects that are here, chlorophyll, suspended sediments, and CDOM. And we could also derive IOPs, absorption and scattering of different matters in the water, and the KDs, the coefficients of transparency. The thermal radiometer is the SLS2024. It's the sea and land surface thermal radiometer located here, and is the one that is used to derive the sea and sea ice surface temperatures in the skin of the water. And then we have the SAR radar altimeter here to produce the sea surface, to measure the sea surface height. So all these microwaves and location sensors that are here are all related especially to the altimeter, to have a good geolocation. So we don't really, let's say it's a group of sensors, the SRAL, the microwave, and the GNSS. So I already mentioned that the EUMETSAT operates the satellite in level 1 and level 2 and supports Copernicus for the level 3 and level 4. And you can access the EUMETSAT data store and download these level 2 levels directly as a user. And there is a nice web GUI to download the data. This data is also redistributed in the United States by NOAA. And there are also some other atmospheric products available through EUMETSAT, but the Sentinel-3 land products are redistributed by ESA. So you have to go to other data provider or the other viewer or the web GUI to access land products. Okay. Well, why Sentinel-3? So there are many reasons. I just wanted here to show you very, very quick, no, the 21 bands that are um, where OLCI is measuring, this radiometer is measuring. So we have the ultraviolet is not covered. We have in the blue, all the visible range of the spectrum, close, going to longer wavelengths into the red and near infrared bands too. So we have a high number of bands. The signal to noise ratio is high. So the higher is the signal to noise ratio, the better. And there are a good number of options for flexible processing. So we have EUMETSAT delivers a standard level 2 product that is atmospherically corrected, and it contains already water quality products in it. But there are other atmospheric correction possibilities, like case 2 ACC that we will see if you want this afternoon, or polymer or acolyte that maybe they are familiar to you if you work with Sentinel-2, because they are also adapted to Sentinel-2. So this is one image of the Gulf of Mexico. This was, this was I have another image that I put in the share folder for you that I think it was before the hurricane, the Milton hurricane, which is quite impressive because you see the hurricane and then the waters that are already mixing, and it's quite impressive. So some specifications of OLCI. The swath is 1,270 kilometers. It takes the images in full resolution, that is 300 meters pixel. But there is an option for if you need a broader area and you don't need so much detail, they convert this full resolution into reduced resolution in 1.2 kilometers. And it has 21 bands from visible to the short wave infrared. And some of the bands are used for atmospheric correction. That's why when you go from level 1 to level 2, you have a different number of bands. So in the level 2 product, you only have 16 bands. Usually is because the ones used for the atmospheric correction are not stored anymore. And that's because they need the space. Okay, it's a matter of space. Okay. Very good signal to noise ratio, and the configuration is you see here is not really looking into the nadir. It's a bit tilt to avoid the sun glint, and it has 5 cameras. This video I'm not going to show it because Shuba showed it yesterday, so we can pass. Problems, all the problems with the visible, the optical sensors, clouds, right? If you are not interested in studying clouds, which is the case for us, you have a big problem. And Earth is cloudy, and the clouds move and change and grow, and so we need to be able to identify them correctly. So that's why it's very important when you work with remote sensing data to look at the flags. And I think Lachlan yesterday did a good job when she showed this table with all the flags and explained you how they were derived, because you have to use them. Okay. If not, you can be introducing false data, false measurements in your calculations. I insist on that because I think we need to insist on that because I've seen things. Okay. The coverage, Sentinel-3A only, and 1 day only, it would look like this. There are some strips, and there are some gaps of data. If we use 2 of the constellation in 1 day, or some of these gaps will be already filled. So we have even more data. If we have 2 constellation, the constellation in 2 days, we almost have an overview of the whole globe. In 2 days, we can complete this view of the world. And of course, adding days means more and more data. Another problem for the polar LEO satellites is that it's seasons. Okay, rotation of the Earth and how the ice covers the poles and a big part of the high latitudes for 6 months in each part of the globe. So from the 85 degrees on, the sun zenith angle is too high, and in winter, in this case, in the northern hemisphere winter, we won't have data. Okay. From 70 with a sun zenith angle of 70 to 85 degrees of sun zenith angle, that means you see here more or less from the 41 latitude to the 60 latitude, we have data, but we have to be cautious using this data because we can have higher uncertainties and higher errors. Okay. The same happens in the northern hemisphere summer, that is in the northern hemisphere, on the southern hemisphere winter. Okay. And in this case, it's even worse because the sun zenith angle of 70 degrees or higher, starts practically in minus 28, 30 degrees. So all this data in the southern seas also has to be used with certain cautions. It's not that you cannot use it, it's just that you have to be careful. Okay. Also for ocean color, the parameter that we derive for ocean color is the algal pigment chlorophyll A concentration. I talked about this already. I'm not going to repeat myself. And I put here for your interest, you can find this in also ESA has a Sentinel wiki, and all the information of the different sensors is in this wiki, and it's explained with a lot of graphics, etc. And this, I took this table from that wiki, and you see here the signal to noise ratio, so you can compare with other sensors too. And you see in the visible is pretty high, and then it's losing some quality when we go to the sphere, near infrared sphere. So this is a global map of the chlorophyll A produced with OLCI data. It's probably an annual product. That's already a level 4 product, okay? And about the levels, I want to insist a bit, if you have a few minutes, because NASA, NOAA, European Space Agency, EUMETSAT, they try to use the same terminology, but there can be small changes. So this is the one that is used by EUMETSAT. So the level 0, on the contrary, that NASA is not delivered to users unless you ask for it because you are a scientist working on calibration or whatever. So they are not going to give you the level 0 right away. They deliver level 1 in different, I put here A, B, C, because for instance, for OLCI data, they deliver level 1B. It's different processing, levels of processing, not only calibration but system because calibration or geolocation, etc. They keep adding things. For instance, if you have worked with Sentinel-2, some of you have worked with Sentinel-2. You have a Sentinel-2 level 1C, which is TOA reflectance. So it's not TOA radiance, but TOA reflectance. It has been a small correction. So you cannot really compare TOA reflectance with L1B OLCI because there is a difference. You will have to correct Rayleigh or something in the level 1B OLCI. The level 2 is the geophysical variable already derived. There is an atmospheric correction done, geolocation done properly, and even they put algorithms to derive geophysical variables from the water. So we usually have water leaving radiances or reflectances, plus, in some cases, IOPs, plus concentrations. And then the level 3 and level 4, the ones that are already produced by Copernicus, are more like pinning products of mosaics or gridded maps, of the different variables. Yeah. So this terminology here, that these IDs are the ones that are used, that the UMESAT data store uses. This is important for us, and you will see them in the Jupyter notebooks. So just to have an idea what they have, the 0407 is the full resolution level 2 data. We will also use the full resolution level 1B data, that is the 0409. So these numbers will come up later, so that's why I put them here. Yeah. Well, I put here some of the changes that will come in the future. Go fast through them too. So right now, UMESAT delivers level 2 data that is atmospherically corrected geophysical variables with a standard atmospheric correction. Some of the geophysical variables are also they have two concentration values of chlorophyll, for instance, and this second concentration value is derived using case 2 RCC. And there are some differences in between the there are some differences in between the product that UMESAT is delivering and the one we can produce with a case 2 RCC algorithm in a SNAP. There are small differences, but there are some. Okay, just for you to have this into account. I encourage you to learn more about the flags. If we have time, we will go through the case 2 RCC presentation, and I will show you some of the flags that are useful. And well, there are some links there for OLCI processing. We will use some of the materials that are there. There is also another note. Yeah, and we are now working with collection 3 data. So you know that the satellite data suffers several reprocessings through the years. As soon as some algorithm is improving something, they want to include it in the processing chain, and so there are different collections of data. Right now, in February, they started this from the collection 3 to include some improvements. So we are now in the collection 3 evolution 3.04, but for the second quarter of 2025, they will reprocess everything to collection 4. And these are all the new improvements that are going to be made. So then there is a redevelopment of the standard atmospheric correction. There will be a BRDF correction for water reflectances products, some improvements in the algorithm to calculate the chlorophyll. They will add the fluorescence of the chlorophyll as a new parameter, new flags for clouds, as I told you, etc. And well, some more details on all these things that I just mentioned. I know you have the presentation. You can read them there. We don't need to go through this. Okay. There are links in each of these new improvements for you to go to the ATBDs or the documents that explain how they are going to do this and what is the improvement they are introducing and why it's better, with validation data, etc. I also want to mention, we won't see it here, but there are some, I put here the acronym. There are some tools for validation. So usually one of the main issues we have when we produce something is that we need in situ data to validate, and we don't have the in situ data. But there are some places where we can go and try to find this in situ data to validate our products. And there are some developed tools to do this validation, like Thomas. I wanted to do this. I mean, it's impossible in one day. so it's impossible. But Thomas is a validation tool for several sensors, and you can access to it here. It's open source, free, and then the HyperCP toolkit 2 in collaboration with NASA for the validation of space and Sentinel-3. Okay, there are more things, but we are running out of time. Just to let you know, in the practicals, what we will do will be we will access the UMESAT data store, but instead of doing it graphically with a web user interface, what we will do is to access through an API. And that's why you need to have all these things in place. And that's what I will do in the next slot, is just to explain you how to do it for doing it properly, but we won't be able to go to all the it's impossible. We won't be able to go to all the Jupyter notebooks, but at least we will have them ready to work by yourself the next time, so you won't have any problem. That's my objective here. I'm not going to try to do everything, because as we have seen, it's not really possible. And well, UMESAT, beyond or besides the data store, it has other data services. If you are like INCO is here, a big institution, and you want to use the UMEDcast system to receive directly the data as a ground station, basically, to receive some of the data directly. Or if you have, you know exactly which data you need, so there is a way of specifying, I want this data every day download into my system. You can do it with a data tailor, or there are also some viewers, just to, if when you start working with something and you don't know what you want and you don't know what it is, you can go to the UMED view and check what are the products of your interest, and then go to the UMESAT data center or the UMESAT data store and download that. Okay. Woof, it was really, really fast. Have you seen this slide before, or is it the first time? That's a very short explanation on what is the Copernicus program. And just to stress again, so ESA and UMESAT are the satellite data providers for the Copernicus program. The Copernicus program is not only satellites, but an important weight of the program is the satellite data. So the space is coordinated by ESA, by UMEDSAT, and other missions. And as I told you, UMEDSAT delivers the marine data, for instance, from the UMEDSAT. We can obtain data from JSON, Sentinel-6, Sentinel-3, but only the marine part. I insist on that. Sentinel-4 and 5 when they are launched, and other small Earth explorers, science satellites. And ESA is delivering data from the SAR, Sentinel-1, the MSI, Sentinel-2, and the Sentinel-3 corresponding processing to land, not to the marine. Okay, and then land surface temperature, some other missions that will come in the next week. And these are the different services. The Copernicus program has 6 different services: atmosphere, marine, land, climate, emergency, and security. And they are implemented by these organizations. And they are also now starting, well, it has started already, but it's not as operational like the satellite distribution, to try to also be a hub for in situ data, which is really very important. In situ data, you know, that because probably you measure some of them, that to get to share it is like a bit difficult, because you have to pay for it. It's a lot of work, etc., and it's not so easy. So trying to engage the scientists to share this in situ data.